Lesson 7.1 is on the multiplication properties of exponents. In this video, we're going to learn how to multiply monomials as well as simplify expressions involving monomials. Vocabulary for this section: monomial and constant. So what are a monomial and a constant? So a monomial is a number or a variable or the product of a number or one or more variables with a non-negative integer exponent. It has only one term. So remember, a term, if you have a list of things, like if I have 2x squared plus 3x, this would be two terms. Terms are separated by plus or minus. So a monomial would just be one term. Okay, and the exponents have to be positive and whole numbers. Okay, so this is an example of a monomial because we have one term, there's no addition or subtraction in this thing, and all of our exponents are positive and whole. Okay? An expression that involves division by a variable, like AB over C, is not a monomial because you're dividing by a variable. You can't have a variable in the denominator. That would not be a monomial. Okay? A constant is a monomial that is a real number. Okay? So a monomial, just a constant, just a number. There's no variable in it. So like 3 is a constant, 3.5 is a constant, 4.7, any of those, pi, those are all constants. So those are all monomials. Okay? Those are all constants. The monomial 3x is an example of a linear expression since it has an exponent of 1. The monomial 2x squared is nonlinear because its exponent is a positive number other than 1. Okay? So we want to determine whether each of the expressions is a monomial or not and explain our reasoning. So in this one, this is not a monomial because it has that minus. So this is two terms. So this one's going to be no. This one here, we have 8f squared times g. We don't have any variables in the denominator. All of our exponents, they have 2 and 1, which are both positive whole numbers. So this one is going to be yes, this is a monomial. Okay, here we have 3 over 4. That's just a real number. It doesn't have any variables in it, but it's also still one term. So this is still a monomial. It's also a constant. Okay, and number 5D, 5 over t. This one is not going to be a monomial because we're dividing by t. Okay, so remember we can't have a variable in the bottom. Okay, so you guys look at these and say which one of these is a monomial. Okay, next thing we want to do is look at the product of powers. So to multiply two powers that have the same base, you add their exponents. So for any real numbers, a and any integers m and p, a to the m times a to the p is going to be the same thing as a to the m plus p. So when you have the same base and you're multiplying, you can add your exponents. So here, if we think about b to the third times b to the fifth, it's going to be the same thing as b to the 3 plus 5 is b to the 8th. Let's look at why. You guys remember what an exponent is. If I have b cubed, remember that's the same thing as b times b times b. It's b times itself 3 times. And b to the 5th is going to be b times b times b times b times b. So if I have b to the third times b to the 5th, that's going to be this times this, which is going to be b times 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 b. And I have a total of 8 b's. So this is the same thing as b to the 8th. Okay. So when we're multiplying things, we want to get everything together. So if we're looking at this first part here, this is technically 1 times r to the 4th. And then it's times a negative 12 times r to the 7th. So what I want to do is I just want to get like things together. So I want to get all of my numbers together. I want to get all of my r's together. So I'm going to say this is the same thing as 1 times negative 12 because you remember multiplication is commutative. So we can rewrite this in any order we want and it's still going to give us the same thing. So I'm going to multiply my numbers. 1 times the negative 12 is negative 12. r to the 4th times r to the 7th. Remember, we have the same base, and we're multiplying. We're going to add the exponents, and I'm going to get r to the 11th. So negative 12r to the 11th is my final answer. Okay, same thing with this one. I'm going to rewrite this so like things are together. So I want to move my numbers together. I'm going to do 6 times 5, and then I'm going to put my c's together. So I have c and c to the 5th. I'm going to have c times c to the 5th, and then I'm going to have d to the 5th times d squared. I want to keep like things together. So now I'm going to go simplify each of those like things. 6 times 5 is 30. C times c to the 5th, this is technically c to the 1st. Anytime there's no exponent, you can assume there's 1 there. So we have the same base. We want to add our exponent. So this is going to be c to the 1 plus 5, which is going to be 6. So c to the 6th. And then here we have d to the 5th times d squared. So same base, we add our exponents. 5 plus 2 is 7. I'm going to have d to the 7th. And that's my final answer for part B. Okay, so you guys try this one. Okay, same thing with this one. We want to keep like things together, so you guys do this. Okay, next thing. To find the power of a power, we want to multiply the exponents. So for any real number, a, and any integers m and n, a to the m to the p, is a to the mp, m times p. So the reason that this works, if we look again at the b example, so b to the 3rd to the 5th, right? So anything raised to an exponent is just saying it's the same thing as itself multiplied together. So this is going to be b to the 3rd times 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 b to the 3rd, 5 times, right? And each of those b to the 3rds is b times b times b. So then I'm going to have b times b times b. And at the end of this, I end up having 5 groups of 3 b's for a total of 15 b's. So that's the same thing as b to the 15th, which is the same thing as 3 times 5. So when you have a power to a power, it's the same thing as multiplying those exponents and getting what that is. Okay? So if I want to simplify this, I want to start from the outside and work my way in. So I'm going to first look at these. 3 to the 2nd, I can multiply those together, and I'm going to get 2 to the 3rd. That's this part here, still there. And then this part here becomes to the 6th. So now I have 2 to the 3rd to the 6th. And now I can apply the power rule again. Power to a power, we multiply. So 3 times 6 is 18. So it's going to be the same thing as 2 to the 18th. If you wanted to put that in your calculator and figure out what 2 to the 18th is, you could. And 2 to the 18th is 262,144. Or you can leave it like this for the sake of simplicity for now. Okay? So you guys try this one using the power to a power rule. Okay, now we want to find the product of a power. So to find the product of a power, you find the power of each factor and multiply. So what this is saying is that you apply that power of 5 to each thing that's being multiplied inside the parentheses. So if I had 2x squared, let's just do the simpler one for now, to the 3rd. I'm saying that this is the same thing. Remember power rules? If you have something raised to power, the same thing as 2 times x squared times 2x squared times 2x squared 3 times. Okay, so when I do this, I can do the same thing I was doing before by grouping like things. So I'm going to have 2 times 2 times 2, and then x squared times x squared times x squared. So now this is the same thing as 2 to the 3rd, and this is the same thing as x squared to the 3rd, because I have 3x squared. So we can see that this cubed applies to both of them. Now I just want to go through and simplify this. So 2/3 is 8, and then 2x squared, x squared to the 3rd. You multiply your powers, and that's going to be x to the 6th. So that's how this would simplify, by using this power rule, where you apply it to each part. Okay, so we want to do the same thing with this example here. So they want us to find the volume of a cube that has a side length of 5xyz. So if you guys remember a cube, all the sides on a cube are the same. So this is 5xyz, this is 5xyz, and then this one is also 5xyz. So if I want to find the volume, it's length times width times depth, that's going to be this thing times itself 3 times. So this is the same thing as 5xyz cubed. And so using my power of a product rule, I'm applying that power to each thing. So what is being multiplied here? I have 5, x, y, and z. So I have 4 things inside here that are being multiplied. And I want to apply the power of 3 to every single one of them. So I'm going to say the same thing as 5 cubed times x cubed times y cubed times z cubed. And then I just want to simplify this. So 5 cubed is going to be 125. And I can't really simplify any of this anymore. So it's just going to be x cubed, y cubed, z cubed. And that's going to be my final answer there. Okay, you guys try this one to find the surface area. Remember, surface area is the area of each of the sides. So if I want to find the area of this here, I'm going to do my length times width. And then I'm going to do that times 6 because this is a cube. They're all going to be the same. Okay, so I'm going to do 6 times 2p cubed squared. So figure out what that comes out to. Remember, the 2 only applies to the thing inside the parentheses. Okay, last thing we want to be able to do is simplify expressions. So to simplify a monomial expression, we want to write an equivalent expression in which each variable base appears exactly once. There are no power of powers, and all fractions are simplest form. Okay, so we want to get all of our variables together so we don't have 2 x's in one equation, and we don't want to have any power to powers, and we don't want to have any fractions that are not reduced. Okay, so if I'm looking at this might look scary to start. Let's start first by looking for power to the powers. So the only power to a power here I have is this 2 to the 2 to start. So let's start by simplifying that 2. So it's going to be 8g cubed h to the 4th, and then that 2 becomes 4. And then I still have 2g h 5 to the 4th. Now I want to apply these powers of 4 to everything inside of the parentheses. So here I have 8g cubed and h to the 4th. Here I have 2g and h to the 3rd. So 8 gets to the power of 4, g to the 3rd gets to the power of 4, h to the 4th gets to the power of 4, 2 gets to the power of 4, g gets to the power of 4, and h cubed gets to the power of 4. Now again, I want to go through and simplify any power of powers I have. So 8 to the 4th, I'm just going to leave for now. G cubed to the 4th, you multiply those powers, power to power. So we get g to the 12th, h to the 4th to the 4th, power to power again. We multiply our exponents, so we get to the 16th. I'm going to leave the 2 to the 4th for now. And then g to the 4th, I'm going to leave. I don't have a power to power. H cubed to the 4th, I'm going to multiply, so I'm going to get h to the 12th. Then I want to group things again. So I'm going to have 8 to the 4th times 2 to the 4th. My g's, I have g to the 12th and g to the 4th. And my h's, I have h to the 16th and h to the 12th. And I want to go through and simplify this. So 8 to the 4th is 4,096. And then 2 to the 4th is 16. So I'm going to multiply 4,096 times 16. So I'm going to get 65,536 there. Powers, when you have the same base and different powers and you're multiplying them, you can add their exponents. So 12 plus 4 is going to be g to the 16th. Here, 16 and 12, again, we have the same base, different powers. You could add those powers, so it's going to be h to the 28th. And that's going to be our final answer for this one. So you guys give this one your best shot. And that is the end of lesson 7-1.